So in this video, I am going to show you some alternative ways to generate confidence interval data for statistics that aggregate over time-persistent data sets from ARENA. Now normally this would be done in the ARENA reports. It'll do this for you, but some students have pointed out that if ARENA is installed on a Windows machine where there are certain software incompatibilities, then the Crystal reports that's embedded within ARENA may fail to load even entirely. Even if it loads, sometimes the category overview doesn't load. So we can't get around this if we're going to continue to use ARENA, and so we need alternative ways to calculate these confidence intervals without using the reports, and that's what I'm going to talk about here. Now normally we could use the output analyzer to do this, but there's a couple of extra steps we need to do to make the output analyzer work the way we want it to work with these time persistent aggregates. So let's get more concrete to see what I mean here. I've got model 7.1 up, and so as instructed I go into the statistic module under advanced process and I create a new row here. And I'm going to call this total WIP, and it is going to be a time persistent statistic. It's sort of a time persistent measurement, which basically means it's going to keep track of the total WIP for every instant of the simulation and output a whole data set from each replication, which is the whole trajectory of the total WIP. So the expression that I'll use here, if I don't remember what to type in here, I can go to build expression, and I want this WIP to sort of tell me the WIP aggregated across the three different part types. And so as the book describes, I can go to basic process variables, entity, number in process, and then under entity type, I can select part 1, and then I can hit plus, and then part 2, and then hit plus, and then part 3. And if you remembered this entities WIP, you could have just manually typed that in this expression here. It's collected over the entire replication. I'll call it total WIP, and I'm going to put it in a file called total WIP as well. Now, if I'd like to see that while I'm running this replication, I can then go into here and I will add a plot. And it brings up this thing here. I can say add a data series. The series name, I guess I could also call total WIP. And then under the expression here, then I am going to again go to build expression, and I will then look under advanced process variables, statistic, time persistent, and I am going to select last recorded value, and then under dstat name, I will then put in total WIP. And so this means that it's going to plot at every instant of time the last recorded value in this total WIP data set. So I'll click OK, and then just to make it look clean, I'm going to click on this axis tab. Under the time axis, I will go to down here to scale, and I know that I've configured this for minutes, and I'm going to configure it to run for 5 days maybe, so I will then do 5 times 24 hours times 60 minutes an hour, and that tells me there's 7,200 minutes. So my maximum here is going to be 7,200. And then under my y-axis, I don't know what the range of the WIP values are going to be, but let's just say I think I have a good idea they're probably going to be 50, and maybe I'll make the major increment on the graph 2. So if I go down here and click OK, it'll say where do you want to put this graph, and I'll maybe put it here. When I do that, it puts this legend, which is just kind of taking up space. So I'm going to go and say legend, turn off the legend, and now I get something that looks like this. So if everything works, when I hit play, then I see that the WIP is accumulating over here for this replication, and this is what I mean by a time persistent data set. At every single instant of time, I can ask, what's the WIP? And so if I were to pause right now, it says the WIP is something around 8 or so, and so I could count all down through here, and I could see that there should be 8 parts sitting around across this thing in the system. So let that thing run, I could eventually let it finish, and then this would populate this whole trajectory. Now, I am not interested in seeing the animation. That was just sort of debug that or verify my total WIP was working. So if I go to run and setup, if I go to run And run control, I could turn on a batch run, and then I'll look under run and setup, and I see I'm running 5 replications, a warm-up period of 2, replication length of 5 days, base time units minutes. So if I were to run this thing and see the results in Crystal Reports, under the category overview, if I go into user specified and then time persistent, I find that the total WIP has an average and a half width. An average of 15.8, a half width of 7.08. And so if I were to go into each replication here, then I'd see that each replication itself has a certain time persistent WIP, total WIP. And what this is saying, for this replication, the average time underneath the time average of the total WIP, which is basically the integral underneath that curve divided by the time interval, was 11.6. And what this half-width correlated means is just means that when it tried to take small portions of the replication to generate batch means within the replication in order to try to generate samples with a half-width, it couldn't. And so, so that's why there's no half-width defined per replication. If I let these replications run for longer, it probably could. But in the category overview, it's just looking at the average for the whole replication. And then that, and so that is what that half-width is defined for. So there are 2 ways that I can generate these averages and half-widths without using reports, the ARENA reports. So one way to do that, if you're comfortable with Excel, is to go into the Tools menu and then go down to Export Summary Statistics to CSV file. And by the way, I'm just showing you what's in this recipe that I've got over here on this PowerPoint slide. So you can find this, it's the last slide of the presentation that's online. So under Report Database, I'm going to grab the database for this model. It's going to dump out to a CSV file. Export complete, great. So if I then open up Excel, and then open Lab 9, Summary Stats, CSV, then I see my 5 replications here. And for every single stat that comes out of here, let's widen these columns a bit. For every single stat that came out of the experiment, I've got data here. So I've got, for this particular stat, it tells me the statistic type, it tells me the database name, it tells me a bunch of info about it, and then finally, for all 5 replications, it shows me the value. If I scroll down to the bottom here, I see total WIP. And I see now the total WIP per replication. So if I want to mimic what went on here, and it looks like I accidentally clicked away from that, I can say, all right, well, what if I calculate, I'm going to do equals average, and I am going to then take an average across these things, and I get 15.80003. There you go. That's that average. That's exactly what Crystal Reports was doing. So now we want to get the half-width. Now, it turns out there's lots of different ways you can do that in Excel. So I'm just going to write above here average so that I remind us that this is the average. In fact, what I could do maybe is let's just freeze these columns. So freeze panes so that now that stays up there. And I will then, this here, instead of putting that title there, I'll just put average right there so that I remember that's what that column is. And then here for this one, if I want to manually calculate the half-width, then I need to know the standard deviation for this. So I'm going to do stdev here to here. And unless I'm incorrect, by default, Excel uses the proper formula for standard deviation that divides by n-1. In other words, it calculates standard deviation by estimating the mean, and then since it used the mean estimate to get an unbiased estimate of standard deviation, it divides by n minus 1. So this should be the same standard deviation I got if I manually did that. And if that's the truth, then I should hopefully get a half-width. It'll be close to this one when I finally go out and do it. So I'm going to write standard deviation in this column to remember that that's what that is. And then the other thing that I need to calculate the half-width is that critical t-value that's usually around 2.0 if I have high numbers of samples. I can look it up in the back of the book, but I'm going to use t.inv. And t.inv gives me a one-sided t-value. So I should be able to put in 0.05 and then degrees of freedom. Well, remember for degrees of freedom here, I do n minus 1. So I'm going to do 5 minus 1 in this case, or 4. And since it's one-sided, I want to divide this 0.05 by 2. And that will give me that critical t-value. And it looks like I need to do 1 minus this. So yeah, I think that will end up being correct. So what I've done here in this, I've calculated the one-sided critical t-value, and I've made sure I got the positive value. So I'm effectively putting 0.975 into here, which is just 1 minus 0.05 divided by 2. And so this is the alpha that I would normally get. I divided it by 2, and then I took the 1 minus to get that critical t-value. Now it turns out that Excel, so I'll put t.inv here to remember that that's that thing there. It turns out Excel has a deprecated function that is tinv without the dot, that is a two-sided. So if I did this right, then I think if I do 0.95 instead of 0.975, and my degrees of freedom will be 4 as well. Yeah, there we go. So so this is the confusing part. It was confusing to me, so I had to do my gut check here. So I got the same number here, but this t.inv is the one-sided critical t-value, and in order to make that work, I had to put 0.975 in. So I'm going to just manually put that in there, 0.975, and then my 4 there. And so this gives me my critical t-value. Now, if you forget the dot, you'll use a deprecated Excel function called tinv that gives you the two-sided critical t-value, but the p-value you put in is a sort of like on the flip side of things than the other one. So the arguments are sort of very different on these two, but if you know what they are and you play around with it, you can end up getting the same critical t-value. And so my hope is then, so I'll put tinv up here, since those are both the same, I'm just going to use one of them, that if I want to actually calculate my half-width, that, if I remember my half-width formula, is just the standard deviation divided by square root of the number of samples, and so there were 5 samples here, and that's effectively the standard error of the mean. So maybe I'll make this SEM just so we remember what that is, and then my half-width I'll put in this next one, and so the half-width is just the standard error of the mean times the critical t-value, and there we go, the 7.08. So it took a while, a few steps here, but I end up getting the average and the half-width by manually calculating them. And if you're clever, you can combine all of these formulas into one, and you can manually calculate that. And you're done, you do it once, you run this thing again, you do those same formulas. Now, fortunately, Excel knows that you're going to be doing this a lot, so they have their own function called confidence.t. So I am going to put that, I'll do conf.t in this column, and then I'll say, well, what if I just wanted to say, have Excel do all this for me? So I'm going to do confidence.t, and then I'll put an alpha of 0.05. I'll put my standard deviation that I've already calculated here, and I'll put my number of samples, 5. And if I do that, it gives me the same value out. So that's how in Excel you can calculate the mean and the half-width in one shot. So you just use this formula, which is up here, confidence.t, where you put your alpha value in, you put your standard deviation. So if you wanted, I could have just done stdev and then whatever this is, F66 through J66, and then my number of samples here. And I could probably do something clever like F66, J66, and then this formula here gives me my half width, and this formula here gives me my my mean. And then those two together give me my confidence interval. So if I really wanted to know what the lower and the upper bounds of the confidence interval are, then I can just create a one here that does mean minus the half width, and then I can do mean plus the half width. And that right there are the bounds of my confidence interval. So that's how to do it in Excel. Now, some of you may want to be able, or may want to try to do it in the output analyzer instead. So let's see how to do that. So the problem right now with doing it from this data file that's come out of here, well, if I go into the output analyzer, I can go to graph, and I can go to plot, and I can add this data set. So I'm going to hit browse for this data set, and under lab 9, oh, I didn't actually, it looks like I haven't saved out the data set yet. So if I go back to here, go to window, go to run mode, I'll stop this, go to the statistic, and I will then make sure it has an output file, but I may not have put it in the right folder. So in lab 9, oh, I forgot to put my totalwhip.dat. So if you don't end in .dat, then sometimes it doesn't show up there in the output analyzer. So I'll run this again just to generate those data again. Would I like to see the results? Now I'm going to say no. Actually, maybe I will. Well, we've got it saved in Excel. So I'll add a data file, total whip. I want to do all replications for the plot. And that shows me these plots, which look just like the plot that I was showing during the runtime. Now the problem is, some of you are going to go to analyze, and you're going to want to do confidence interval on mean, and then say classical. And if you click add, and then click on this total whip data file that you just generated, and you might say, well, I'll do lumped because I thought that was what I was supposed to do. If I hit OK, it says, it contains time persistent data. You must first batch truncate the data. Now really what it's saying is that it's confused because it doesn't know how to calculate a confidence interval for these data. Like, what does it mean to calculate a confidence interval when you have 5 data sets and each data set spans over 7,200 minutes? So what we need to do is turn each data set into a time average so that each replication has a single time average, and then it will then generate the confidence interval across that. That's what in Excel, Arena already did for us. So if I go back to Excel, these all are time averages under each of these replications. So replication 1, which is the red line, this red line here, if I were to take the integral under that red line and divide it by 7,200 minutes, then I would end up getting this value, 11.683. That was already done by Arena, but I didn't save that out anywhere, and so the output analyzer can't generate a confidence interval for me. So how do I save that out? Well, if I hit stop, I go to advanced process, go to statistic, then I can generate an additional statistic, which I will call average total whip. And it is going to be an output statistic. An output statistic only outputs at the end of the simulation. And so it is going to aggregate over the time persistent statistic and then give me one number at the end of each replication. So I will, for the expression, I'm going to go to build expression, and I am going to go up to advanced process variables, statistic, and then time persistent, and I want to take the average value of total whip. So I generated one statistic called total whip, and now I'm generating a second statistic which will take the average across that total whip statistic, or really total whip data set. And then I'm going to save that to an output file which I'll call average total whip.dat. And if I then run this thing, again, I won't see the results. If I now should be able to go into analyze in the output analyzer, compare means, analyze, and then confidence interval on means, classical. I'm going to get rid of this one because that was a failure, and I'll hit add. go to Browse, find my average total WIP. I want to select Lumped because I want to generate a confidence interval that takes all 5 replications and bundles them together into one data set and take the confidence interval across that data set. So if I do that, then I hit OK, then I end up getting this confidence interval. And if I look at this confidence interval, it says it has an average of 15.8, a standard deviation of 5.7, and a half width of 7.08. Now let's compare that. If I go to my Excel spreadsheet here, then I can see that I was expecting an average of 15.8, a standard deviation of 5.7, and a half width of 7.08. And so that is exactly what I got out of Excel. It's exactly what I got out of the reports. And so if you're looking for alternative ways to generate confidence intervals of statistics that aggregate across time persistent data, you can do that. You can do it in Excel, and you can do it in the output analyzer. If you want to do it in the output analyzer, you have to generate an additional statistic like we did over here. And that additional statistic is going to need to be an output statistic. So I accidentally created a separate statistic. And that output statistic is going to do the average over the replication to give you one number per replication. But if all you care about is the average over the replication, then Arena actually does that for you automatically. And if you use Tools, Export Summary Statistics to CSV file, and then view that CSV file, then all of your time persistent statistics, so here it is, this total WIP is a time persistent, but it is, instead of giving you the entire time persistent statistic, it just gave you that time average underneath it. And there it is right there. And so we take 5 of those together and we can calculate it manually. So those are 2 ways to get around using Crystal reports and generally just get more familiar with getting data out of Arena.